Well, hello and welcome to this exercise on enlargement with negative scale factor. It also takes in rotation and transformation metrics. Now, there are two parts to this question. The first part is certainly okay for anybody doing iGCSE mathematics and for GCSE mathematics as well. Now, the second part is a bit more difficult, and I think that should be okay for anybody doing iGCSE additional mathematics or even for further pure maths 1 and also for high school geometry. Now, here we go. We got object A, which has been transformed, or is it describe fully the single transformation that maps triangle A onto triangle B. That bit should be okay for iGCSE and GCSE, and it then says confirm your answer using transformation metrics. Now, that one should be additional mathematics on and even for further pure maths 1. Now, two steps here. We need to join the equivalent points from the object to the image. For instance, we're going to join the point 2, 3 on the object to the point 4, 5, sorry, 4, 3 on the image there. That's what we call that. And then we join the points 1, 3 to the point 5, 3 on the image there. That's what we call that. So the red line and the red line and the green line sort of coincide, superimpose. And then we do the join. Then we join the last points there. That's the point 2, 1 on the object to the line 4, 5 on the image there. Okay. Now we want to see if these two lines meet at a point, and the point of intersection would then be the center of enlargement. So in fact, in this case here, the center of enlargement is beside the point 3, 3. Okay. So that is now our center of enlargement because the three lines joining the 3 points or the 3 equivalent points meet at the point 3, 3. So in effect, what you got there is that object A is mapped to object B. So object A is mapped to image B by transformation with center of enlargement 3, 3. Okay. Now, from my center of enlargement to the point 2, 3, if we want to get to the equivalent point from the center of enlargement, I'm going to move in the opposite directions. I'm going to move from there to there, and that's 4, 3. So I'm moving, because I'm moving in the opposite direction, this is certainly a case for enlargement with a negative scale factor. And similarly, if I want to move from the center of enlargement, so to the point 2, 1 of the object, if I want to move from this, if I want to move from the center of if I want to move from the center of enlargement to the equivalent point on the image, I'm going to move in the opposite direction, again confirming that this point now is confirming that our enlargement has got a negative scale factor. Right. Now from the center of enlargement to the point 2, 1 is 1 unit there. And from the center of enlargement to the point to the equivalent point 4, 3 is also 1 unit. The size of this line here on object A is 1 unit. The equivalent size of the on the object B is also 1 unit there. This line here on the object is 2 units. The equivalent line on the image is also 2 units. So then we then have that object A is mapped onto image B by transformation with negative enlargement, with the center of enlargement at 3, 3, with the negative scale factor of -1. Okay, now that makes sense. Enlargement, center of enlargement 3, 3, scale factor -1. Step 2, we now want to find the perpendicular bisectors of the 3 lines joining the equivalent point on the object and the image there. So the red line bisects the first red line, if you remember, from point 223 to point 43. That will also bisect the green line. So we've got two lines meet at the point, and for the blue line, the perpendicular bisector also intersects the red bisector and the green bisector at the point 3, 3. So in effect, we can also transform the object A to the image B by rotation 180 degrees with the center of rotation at the point 3, 3. I hope that makes sense. Now, for the transformation matrix, now because what we've got here is an enlargement where the center of enlargement is not at the point 0, 0. So we have to make an adjustment. Now suppose the center of enlargement is at the point PQ. What we then do is we look at our usual transformation matrix, which is K being the scale factor. We have to take into account that the center of enlargement is at PQ and not at 0, 0. So if we pick any point on the object, say the point x1, y1, we then subtract from x1 the value of P, which is the x value at the center of enlargement, and subtract Q from y1, which is the y coordinate at the center of enlargement there. We do the same thing for points x sub 2 and y sub 2 on the object, and then subtract from x sub 2 P and subtract from y sub 2 Q there. And of course, we do the same thing for x3 and y3 as well. And we come up with the answer. When you do your multiplication, you end up with capital X prime sub 1 and capital Y prime sub 1. You do the same thing for capital X prime sub 2 and capital X Y prime sub 2. And then for the third point, we have capital X prime sub 3 and capital Y prime sub 3. We've not quite done yet. So moving on from there, we should now add the x coordinate at the center of enlargement to our capital X1 sub 1 and add Q, the y coordinate of the center of enlargement, to capital Y prime sub 1. And you do the same for x prime sub 2 and y prime sub 2 and x prime sub 3 and y prime sub 3, and that will give you the equivalent coordinate of at the image there. So in effect, x1 y1 will then become x prime sub 1 and y prime sub 1 there. And for x2 y2, we end up with x prime sub 2 and y prime sub 2 there. Okay, for my example here, let's have a look. In this example, we've got that the scale factor is -1 and -1 there. So the transformation matrix is -1, 0, 0, -1. Now at the point 2, 3 on the object, if you subtract 3 from 2, we end up with -1. If you subtract 3 from 3, we end up with 0. For the point 2, 1 on the object, we subtract 3 from 2, and we end up with -1 again, and subtract 3 from 1, and we end up with -2. At the point on the object 1, 3, at the point 1, 3, we subtract 3 from 1, and we get -2, and we subtract 3 from 3, and we get 0. Now, we shall now do a matrix multiplication using our transformation matrix, and the figures in red and the numbers in red. So for instance, -1 times -1 will give us +1. 0 times 0 will give us 0. 1 plus 0 will give us 1. So in effect, we end up with this 1 here. Similarly, 0 times 1 will give us 0. -1 times 0 will give us 0. 0 plus 0 will give us 0. So we end up with capital Y sub prime, sorry, capital Y prime sub 1 at 0 there. So that will be 1, 0. And for capital X prime sub 2, we get 1 there. And for capital Y prime sub 2, we get 2 here. For capital X prime sub 3, we get 2. And for capital Y prime sub 3, we get 0. Now, for the next line, we now add this bit here, as we did there. We add 1, 2, 3, 3 being the x-coordinate of the center of enlargement, and that will give us 4. We then add 0 plus 3, that will give us 3. Now, this means that for the image, sorry, for the object at 2, 3, the image equivalent is 4, 3. So we got 2, 3 there. The image equivalent is 4, 3. All right. For the point 2, 1 on the object, the image equivalent is 4, 5. And for the point 1, 3 on the object, the image equivalent is 5, 3. Can you make sure that this my arithmetic is correct? Now, thank you for watching. I hope all that made some sense, and please subscribe. Bye bye now.